Hey guys, we got our last lesson today. Don't be too heartbroken on that. Summer is upon us, okay, with this. Hopefully we can get back to a little more of a normal school next year with all that stuff. I'd imagine we would, okay. So last thing we have to talk about today are similar solids, okay. So we're working with similar. Remember before when we worked with similar, it was back in chapter 7 that we were setting up proportions, working with ratios, working with scale factors. We're going to be doing the same today as well. We're just going to be doing it with solids, okay, which means we're going to be dealing with 3 dimensions, okay, rather than 2 dimensions, which does change things a little bit for us. Okay, when we're working with similar solids, there's 3 different scale factors we always have to pay attention to. Okay, the first one would be the scale factors of like heights and sides, etc. Okay, anything that would have a regular label on it, like centimeters, inches, feet, okay, that's all considered one-dimensional. Okay, and if it's one-dimensional, that's actually the stuff we worked on earlier in the year. Okay, where you just set up normal ratios, this over this. Okay, dealing with areas now, it starts to change things a little bit because areas are 2 dimensions. And if you think about the label we would put on areas, it would be like inches squared, centimeters squared, okay, feet squared. So what that means is if I'm working with a scale factor up here and I want to change it to a scale factor for areas, I have to square each part. So I would square the top and the bottom, and that would become my new scale factor for my areas. And then volume takes it one more level. Okay, volume is dealing with 3-dimensional. Okay, and if you put a label on volume, it's cubed. It's inches cubed, it's feet cubed. Okay, so what we would have to do is we'd have to take and we'd have to cube the original scale factor. Okay, one important thing to notice, you can never go from area to volume and volume to area. You always have to work with the regular basic one, okay, the one-dimensional one, and then you can change to the others. Okay, but you can never just go from area to volume. You always have to go back to dealing with the one dimension. Okay, so let's kind of see how this works. We're not going to dig into this a ton, just kind of get a feel for it here today. Okay, so example 1 tells you that you have 2 similar prisms that have surface areas of 98 and 18. Okay, so you have surface area of 98 and 18. Okay, and what they ask you to find is just the regular scale factor. Okay, so that's going back to the bare minimum. Okay, going back to one-dimensional. Okay, then they ask you for the ratio of the height, lateral area, and volume. And we want to see kind of with numbers here how these relate to each other. So this is of area. Okay, it was surface area. Okay, so what I have to do first of all is I always have to make sure I reduce it. You remember when we dealt with ratios, they were always reduced. Okay, so I can reduce each of these by 2, and it would become 49 over 9. Okay, so first thing you want to do is reduce. Now, I'm dealing with area. If I think about that, area is 2-dimensional. Okay, which means these are already squared. Okay, to get back to one-dimensional, which I need for scale factor and for height, I have to unsquare them. Okay, well, unsquaring them is essentially taking the square root. Okay, so to get to my height and my scale factor, I have to square root these. If I square root them, I get 7/3. Okay, so if I want to go from 2 dimensions back to 1 dimension, I have to square root because that's the opposite of squaring. Okay, so that means that this one's one-dimensional and this one's one-dimensional. So those will both have 7/3. Okay, lateral area is 2-dimensional. Okay, so I want to go back to the 2-dimensional. Well, the 2-dimensional was the 49 over 9. Or in other words, I square each of these because again, 1 dimension to 2 dimension, I want to square them. Volume is where we want to cube them because now we're going three-dimensional. Always go back to the original up here. If I cube each of these, I will get 343 over 27. Okay, so these are the ratios I would use if I was going to set up a proportion. If I was setting up a proportion dealing with height, I would use this one. If I was doing a proportion with area, I would use this one. If I was doing a proportion with volume, I would use this one. So you have to pay attention, okay, to which one you should be using depending on which dimensions you're working with. Okay, whether it's one-dimensional, two-dimensional, or three-dimensional. Okay, example 2 actually has us doing a little solving. Okay, so for example 2, so they're saying for each pair of similar figures, find the area of the other figure. Okay, so first thing we got to do is find what matches up, just like we did before. Okay, well notice these two sides match up with each other. So I'm going to start with 8 over 5. Now 8 over 5 is the height. Height is one-dimensional. They want me to solve for area. Area is two-dimensional. Okay, so what I have to do to get to area is I have to square each of these. So I get 64 over 25. Okay. So I cannot use this ratio to solve. I have to use this ratio because I'm dealing with area. So I would do 64 over 25 equals 32 over x or whatever variable you want to use. Okay, so I didn't use the 8 over 5. I had to square them and then I could use it. Then I could work with area because again, area is two-dimensional, not one-dimensional. Okay, so you would go ahead and cross multiply and solve, and you'd end up getting the area of the little guy is 12.5. Okay, for that one. All right. Kind of do the same idea with the second one here. This time you're dealing with a triangle, but that's fine. Doesn't really change anything for us. Okay, so same idea. Okay, the pieces that match up would be the 6 over the 8. And those are dealing with the edges or the sides. Again, I'm going to reduce that down to 3/4. We always want to reduce if we can reduce. Just makes things easier for us. So now the sides are one-dimensional, area is two-dimensional. So I need to square each of these to end up getting 9 over 16. Now I'm dealing in two dimensions. Okay, so that means the 9 over 16 is the one I have to use. And that will equal our 13.5 over x. Again, normal proportion, go ahead and cross multiply, and you should end up with 24 for the area of the bigger guy. Okay, so again, still setting up proportions, you just have the one extra step where you had to square the ratio. Okay, so you could work with area instead of one dimension, which was our side. Okay, next example is the same idea, except now it's going to be volume. It says two similar cones have radii of 5 and 7. It says if the smaller cone has a volume of 500 centimeters cubed, find the volume of the larger cone. Okay, so you don't need to have a picture. If you want one, you can go ahead and draw one, but they give you the radii are 5 and 7. Okay, radii are one-dimensional. Okay, I need to go to volume, which is three-dimensional. So instead of squaring this time, I need to cube them. Okay, again, going from 1 to 3 is going to cube, which gives us 125 over 343. Okay, so because I'm dealing with volume, I need to use this ratio. And And then it tells you the volume of the smaller one. So the smaller one is obviously on the bottom because that's a smaller number. Okay, do your normal cross multiplying and solving, and you should get 1372 would be the volume of the big cone. Okay, so whether it's area or volume, that's taking us from little to big. Okay, we were going from 1 dimension to 2 or 1 dimension to 3. Let's go ahead and flip that then. So for the next example, okay, this time it's the areas that they give us that match up. Okay, so the areas are 153 over 272. Again, first thing you want to do is reduce that. Okay, it does reduce down to 9 over 16. Now, area is two-dimensional. We're looking for sides that are one-dimensional. So we're going from two-dimensional backwards to one-dimensional, which means we want to take the square root. Okay, so back to my sides or my one-dimensional, I want to use 3/4. Okay, so I would go 3/4 equals 15 over x, because now we're dealing with the sides. Okay, cross multiply and you'll end up getting 20. Okay, so that time we were given the areas going backwards, okay, to the side. So going from 2 dimensions back to 1 dimension. Alright, so this time they give us both volumes, so that's where we'll want to start on this one. Okay, so I'll have the volume, I have 270 pi over 640 pi. Again, want to reduce that down, the pi's cancel out, the zeros cancel out, so you're left with 27 over 64. Okay, so after you've reduced them, these are volumes, I want to go back to height. So I'm going from 3-dimensional back to 1-dimensional, okay, which means we want to take the cube root. Not square root, but cube root. There is a cube root button in the calculator under the math key. Okay, we used that earlier in this chapter as well. Okay, so for my height then, the cube root of 27 is 3, cube root of 64 is 4. Okay, so that means 3/4 is the one I'm going to want to use with my height. So I'd have 3/4 is equal to h over 10, okay, which gives us then a height of 7.5 for the little guy. Okay. And we're not going to worry about the last example. I think if we can get this part of it down, we'll be good to go with it. All right? Yeah, so have a great rest of your day. Yeah, we'll have one more video from the review stuff. So I guess I can wish you a happy summer then, and hopefully we'll get back to some normalcy here even more as we go along.